Hello everyone, and welcome to the third webinar of AWS Solutions Architect, a short course presented by IT Masters on behalf of Charles Sturt University. My name is Guy Coward, and I'll be your MC. Your mentor is, of course, Scott Farrell. Just a reminder, we encourage the asking of questions and the use of chat during our webinars, and there are two ways to do so in Zoom. We ask that you direct all course content related questions to the Q&A section and that you send all administration type questions to the support team in chat. You can chat with panelists only or to your fellow students as well, and you can make that choice by toggling through the drop-down box once you've opened the chat log. There are usually some very experienced industry-based attendees who will be most helpful with any queries you might have and can really augment the content that Scott's delivering. We'll have a Q&A session at the end of the webinar, and I'll interrupt if a question is particularly relevant to the slide that Scott's on. But yeah, make sure you post a few questions in there because they're always great. As usual, Barry is around tonight in an administrative and technical support role for IT Masters, and they're responsible for the course Moodle page, learn.itmasters.edu.au. And that's where you find all of the other materials needed for the course for those who hasn't seen it so far. Readings, recordings of old webinars, discussion forums, and quizzes and labs. This week, it's my great pleasure to welcome back Jason Howarth from CSU to talk about CSU broadly and opportunities to learn more about cloud computing and virtualization that CSU and IT Masters offer. Jason, I believe this is still accurate, is a CSU School of Computing sub-dean, and is responsible for transforming online learning and has been an important part of our short course program for years now. It's always a nice time to catch up with him. He is in fact a scholar of MOOCs, or massive online classes. I can't even remember what that is. That's very embarrassing heat of the moment. A scholar of MOOCs, and some of our long-time participants will actually remember assisting Jason with his research. Could you please all welcome Jason, and Jason, could you please cover for me and let me know what a MOOC actually stands for?
That would be massive open online courses. So, can you hear me?
Yep, loud and clear. Thank you very much for clearing that up.
Massive open online courses. There are so many acronyms in computing. It happens to me too, so don't feel bad. So welcome everyone, and I am going to give you a bit of the elevator pitch. It's not going to be long tonight, given you're doing a subject or a MOOC on AWS. Thought it would be opportune to give you a quick overview of the CSU IT Masters programs with a particular focus on the Master of Cloud Computing and Virtualization. So let's kick off, and we will be fairly brief. And of course, if you have any questions, you can follow up. There's some email addresses and contact details at the end of the presentation. So Guy mentioned that we've been associated with each other, IT Masters and CSU, for a long time now. Essentially, it extends back beyond 15 years, where we've been offering postgraduate online degrees for professional IT industry people. So much so, or they've been so popular and have served the market so well that for a long time now we have been the leader in that market segment of IT postgraduate online courses in terms of enrolment. So they've really filled a niche, and they are the preferred destination of many professionals within the IT industry who are looking to upskill and to certify. So just a very quick overview of Charles Sturt. It's a regionally based Australian university, but although we're regionally based, and you can see on the screen there many of our campuses, in fact our main cohort of students are online. So we're one of Australia's leading online universities. We have around 26,000 students enrolled online, and our IT Masters programs, as I said, are the leader in that online space throughout Australia. So although we have lots of campuses, really what I'm talking about tonight are online programs designed for busy working professionals. Now, before I dive in and talk about some of the courses, just a really quick overview of the university qualification hierarchy. So we have typically at the bottom, still a very important award, your undergraduate degree. So you're looking at your bachelor level programs. We move from there to our graduate certificates and graduate diplomas, which are postgraduate awards, typically done after a bachelor's. We then move to a master's, and we'll be talking about some of the master's programs tonight. And from there, we go to a doctorate. So you get to call yourself a doctor, typically a research degree, often not that valuable in terms of industry, although we do also have professional doctorates which can be used by people who want to follow a research pathway in industry. Now, the interesting thing about our programs is that even if you don't have an undergraduate degree, but you have considerable experience in the IT industry, it's possible to get into a master's through a grad cert or a grad dip pathway. So we're not going to ask you to sort of go back and study basics. If you've got 3 or more years in a senior level position within the industry, we would allow you potentially to come into our master's programs. And how this is arranged, you can see there on the screen that we have masters on the right. They're typically of 12 subjects duration, and each master's is also accompanied by a graduate certificate. So if you don't have an undergraduate degree but have industry experience, what you would do is enter through the graduate certificate. So for example, the graduate certificate of cloud computing, and you would do the 4 subjects there. And if you wanted to move into the masters, you carry the 4 subjects across as credit, and then you would have only 8 subjects to do in the Master of Cloud Computing. So 2 awards for 12 subjects, and allows that master's pathway without an undergraduate degree based on your experience. So it's a compelling proposition, and one that many industry professionals have followed throughout the years. So just quickly looking at a sample course, the Master of Cloud Computing and Virtualization. It consists, all of our master's subjects or courses consists of 12 subjects. It is possible to get credit for some of the subjects if you have the requisite industry certifications. We won't go through all the credit pairings tonight. Suffice to say that the cloud computing core consists of 7 subjects that you can see there. Some of these are theoretical, what you would call your typical university subjects. Cloud computing, for example, looks at cloud computing technologies and delivery models. It also looks at governance and security issues. But then you move down, and typically these subjects are delivered through IT Masters. I know that Scott, in fact, delivers a couple of these for us. ITE 531, Architecting Cloud Solutions, and 532, Containers and Virtualization. These subjects that are delivered through IT Masters, they're still CSU subjects, but they typically have a strong industry focus. So for example, ITE 523 Virtualization, it's all based on the installation and configuration of VMware vSphere software. And it also helps you to prepare for the VMware Certified Professional certification. So there's that double whammy of getting a university degree, but also preparing for industry certs. ITE 531, which is based, the subject you're doing now is a subset of that, helps you prepare for the AWS Certified Solutions Architect certification. So you can see there are a nice mix of the theoretical and the practical. So you would do those 7 core subjects. Everyone must do them. That's why they're core. And then you branch into different elective options. We won't go through all these tonight, but you can see we've got what we call academic subjects, which tend to be more theoretical. You need to choose 2 of those. And on the right, you've got your industry elective subjects. They're more industry focused. Often there's an industry certification sitting behind them, which it helps you prepare for, and you choose 3 of those. So really can be tailored a little bit, but is highly relevant to people sort of working or seeking to move into the professional industry that the course is named after. You can go into a web search and find our handbook and click on many of these subjects and find out more details. So what does it look like to study online? Part of my job at the moment is, in fact, all about refurbishing our online environments. I've just done a quick screen dump here of ITC 561 Cloud Computing. This is a snapshot of what it looks like in the learning management system, which is Blackboard. So there's no need to obviously attend classes. Everything you need access to is provided through the learning management system. Typically, we prescribe ebooks. There's activities and links to resources, links to online meetings, and things such as software to allow you to potentially adjust due dates for assessment, flexibility within the learning management system. You can also upload all of your assignments there and get the marks back. The whole thing can be transacted remotely. I won't go into all of the topics, but typically what will happen is for each week that you study within the online learning management system, there's a topic that you click on. There's readings, there's videos, podcasts, everything related to that topic. And typically as well, there's an online meeting with your academic that occurs weekly, which is also recorded. So the whole thing can be done without ever setting foot on a campus. So in terms of entry requirements, I spoke briefly before around how you might get in without a bachelor's degree. But certainly if you have a bachelor or higher in the IT area, you can certainly go straight to a master's. Those with industry experience but no bachelor's degree can come in through our grad cert pathway. Typically we're looking there for 3+ years of professional IT experience, but that we can be flexible there. We would need to look at your resume. If you'd like to know whether you might be eligible, you can go to the web address there, itmasters.edu.au, and fill out what's called an eligibility form. And you can also talk about or enter the various certifications that you have and find out if you might be eligible for credit. So that's like a pre-assessment. You can also go straight and apply, csu.edu.au/apply, and obviously you'll find out about eligibility and credit as part of the application process. In terms of time commitment, about 10 hours a week per subject is the rough rule of thumb that you need to ration for. You can variate your study loads. You can study more than one subject in a session. You can cut back to just one subject. You can even take a leave of absence over an extended period of time. If things get busy at work, you might say, I can't study for this session, and in the next session I might take on 2 subjects. So there is a lot of flexibility and variability there. It is designed to be compatible with people who are leading busy working and personal lives. There's also increasingly variable assessment dates in some subjects. I expect this will be wound out more broadly as time goes by, but what we're talking here is the ability to adjust slightly, when you submit, rather than saying you must submit on the 14th of March, for example, and if you don't submit, then you're going to be penalised. We typically allow a little bit of flexibility up to around a week for submission of assignment material. That will vary from subject to subject. Credit is a really important thing because obviously getting credit cuts down the time and the cost. If you've done any previous postgraduate study, it may be eligible for credit. Industry certifications in the relevant areas and that are current may also be eligible for credit. We don't give credit on the basis of proficiency. So remember that if you have work experience, that can be used as a pathway into the course, but we don't credit the fact that you've worked with AWS servers or something like that. You would need to show either industry certification or previous postgraduate study. Once again, if you want to find out how much credit you might get, you can complete the eligibility form available at IT Masters. Quickly talking about cost, for Australian and New Zealand students, you're looking at $32.50 per subject, times that by 12, that's the total cost. Obviously, less any credit. For international students, we're looking at $34.50 per subject. There's also a small student services and amenities fee. I don't have the exact figure for that. It's around about $22 a subject. you should speak to your accountant if you are looking to do these programs as to whether this stuff can be effectively claimed as personal development costs. You might also be eligible for a loan through the government fee help program, where you're loaning part of or the full cost of the program and then paying that back over time. So there are different payment options there for you. As from last year, we broadened the number of intakes that we're allowing. We now have 6 intake periods a year. So you can choose to start, obviously not in January for 2019, but there's intake periods in July left, September and November. The fees that I showed before are grandfathered. So if you start in those periods, those fees are grandfathered for the duration of your course. There could be some small CPI increases, but not an increase in actual base level fees. It costs nothing to apply. You can see how you go, and you can even start the course and up until census date, a few weeks into your first subject, you can pull out and you're up for no cost at all. So if you're dipping your toe in the water, you can apply, you can study for 2 weeks and find out if it suits you or not. If it doesn't, you can pull out and there's no cost involved in that. So look, if you want to know more about the Master of Cloud, or indeed any of our other IT Masters courses, 2 great contacts there. One is the course director at CSU, Yeslam Al-Sagaf. His email address there on screen. IT Masters, our main man there for talking with is Neil McCosh, neil.mccosh@itmasters.edu.au. Always happy as well to talk to anyone who wants to learn more about the programs. I haven't got my email address there, but it's simply jhowarth@csu.edu.au. So please drop me a line as well if you want to find out more. And with that, I think I've used my 10 minutes. I'll move back to Scott. Thank you so much, everyone, for listening, and good luck with your MOOC.
Thanks, Jason. And yeah, absolutely. Feel free to get in touch with all of us, folks. We love answering questions and talking study plans, so it's always a rewarding experience. Alrighty, we'll say good day to Scott. How you doing? How's your week been?
G'day, everybody. It's been cooler in Sydney this week, hasn't it? I'm just adjusting my screen. That looks a bit better. Yeah, I saw some questions shooting there through about the course. And so the admin people take on questions about the course and course structures, and I'll take questions on later about technical subjects. So I don't know so much about the courses, and they don't know so much about the technologies. So we're looking at databases tonight at AWS, and it's a bigger subject than you might think, and it gets quite complicated. And so we'll make a start. So the more traditional databases that you might have seen are often covered by AWS's RDS solution, Relational Database Service.
Sorry, Scott, just to jump in, could you please share your screen as well? We'll get the slides up as well.
Right. Thanks, mate.
Yeah, right.
I could see them.
That's the main thing, I think.
But I can't tell that they're not shared, so thanks.
Okay, nice.
All right, so here's the relational databases that AWS supports. And so there's a few that are open source, MySQL and Postgres, and then and MariaDB, and Microsoft SQL Server and Oracle, which are more corporate type databases that aren't open source. And Aurora is a Amazon AWS invented database that you won't see anywhere else. So they're the standard offerings. And so it's a managed SQL installation. So AWS help you manage it and support it. So it's just not the database running, but you get some support from AWS as well. And so when I say managed, it's as if you have a database administrator working for you and helping you out. So here's the sort of things you get: automatic updates. And you get software licenses. For the licensed So for Oracle and SQL Server and the licensed ones, you get software licenses as well. So you get automatic updates to the application and the operating system. They're tuned by AWS, but you can make some changes yourself if you need. AWS do the security for you and make sure it's secured. They do your backups. So some of the things are easy to do for yourself, like create the initial database. But then it comes to things like tuning, and you can spend a lot of time and expertise on trying to get your database tuned, but AWS do that for you. And backups, okay, so backups is not too hard. But when you come to backup logs and rollbacks and snapshots and storage, it gets trickier and trickier and trickier to do it yourself. And then how about DR, disaster recovery? That's a bit harder as well. So you want to have a cold standby server in case your main one goes down. And you want the cold one to turn on automatically. Well, RDS can do that for you as well. They have a high availability options as well. So it restarts more quickly. You don't get administrative access. So there's no SSH access on the Linux boxes and no Microsoft remote console access on the Windows solutions. So that's because that's in AWS's court to manage the software and manage the environment, so you don't get access to that. And that's a sort of an important, that question just about gets asked all the time in exams, so that would be a good one to remember. A bit more advanced on RDS. Their automatic disaster recovery takes about 10 minutes. So by default, you've got disaster recovery on all RDS instances. And so if something goes wrong, they'll eventually detect the instances down and recover it from the last backup and apply all the latest logs to it and get it running for you if there's something that just totally destroys the database or the instance. You can have high availability, and they call that multi-AZ, multi-availability zone. So you might have it, say you have your database in Australia, we've got 3 data availability zones, and you'd have it replicated across 2 availability zones. It does cost you more, but the secondaries much quicker to restart than the disaster recovery. And for example, remember I said a couple of weeks ago we had a big Sydney Amazon AWS outage and lots of customers were down for 8 to 12 hours. If you had the multi-AZ database, your database would just start up again in a surviving AZ in Australia, say Melbourne, and it would take 2 minutes roughly to get your database up and going again. It's better than an 8 to 12 hour outage if AWS has a really big outage in their data centers. And you can also do read replicas. And read replicas are there for performance scaling. And obviously it scales out reads, but doesn't scale out writes. So you have a master node and then several read-only nodes to make your reads go faster. Have a look at RDS Aurora. It's very important on their list of databases. So it's a drop-in replacement for either MySQL or Postgres. And the idea is AWS have done a lot of engineering to make it much more cloud-friendly. So they have zero downtime patching. They've got 5 times the performance of standard MySQL implementations. The failover time is much more quicker than the standard DR from MySQL and so forth. They have dynamic storage, so you can add storage without bringing the database down. It's compatible with MySQL up to version 5.6 commands, which is most applications still only support the older commands anyway. And it's much more scalable than MySQL. It's built to be horizontally scalable, and the reads and writes scale much better in Aurora than MySQL, read replicas and so forth. So the idea is the MariaDB and MySQL, we'll just go back to the first slide. While these are open source and available, and MariaDB, MySQL and Postgres, AuroraDB is doing roughly the same job, and your application won't know the difference, but it's faster and more scalable, and it's built cloud ready. And it is more expensive, but it's only more expensive to the point if it goes faster, you might need smaller instances of it. So sometimes it's about, 6 or 1/2 dozen of the other on pricing. A bit of a look about how some of this gets put together. So we haven't covered elastic load balancers at this stage, but they sit at the front of most AWS deployments, and they help you manage horizontal scaling of your application. So these are EC2 instances. Here we've got 4, but it could be more. So something's managing this fleet of EC2 instances, and the load balancer sends out requests to them. But they all come back to the one database. And here we've got M as the master database. And so all the read and write queries are going to this. And this is the S is for standby. That's another common question. It's a multi-AZB standby database. And so AWS can help you manage that. And then here's the backups going out to S3. Database snapshots and database backups and all the logs and so forth going out to S3, but that gets managed for you as well. So running a master and a standby database and doing all the backups correctly and having good performance on it, having good uptime on the database and having disaster recovery, they're all things you'd have to pay a fair lot for someone to set up and to someone to manage, and you need a fairly skilled database administrator to do all that. And you get that with the RDS instances. So this is what I hear from every student, and I hear from clients, I hear from everybody. But I can install my database on an EC2 instance and it's cheaper. Like I've got my EC2 instance and it's doing my website. Can't I just stick my database on there as well? Because I've already paid for the instance. So why would you want to pay the extra for the RDS instance as well? So if you're doing it yourself, you've got no management, no support of the database. You're doing your own backups and logs and rollbacks that I mentioned before. You've got to pay for a database administrator to come in and organize that for you and check it for you and do the backups. Now you have to work out how to scale yourself. So the first day your database is slow, what are you going to do? Make your EC2 instance bigger. And then how are you going to horizontally scale your database? You have to work out how to do that, and it can be quite complicated. How about when your database breaks? And so there's a lot of things you have to do yourself if you start sticking it on your own EC2 instance. And eventually you work out, if you're paying for all this and trying to get this all done, especially if you've got to pay for a staff cost of a database administrator, you best just outsource the database to AWS. Now think about if you give poor advice to your client, you'll end up wearing the failure. So the client will say, well, why did the database break? They'll blame it on you anyway. And not the least thing is you'll start getting answers wrong in exams. So almost always when there's a AWS question about a database, you've got to answer RDS. Otherwise, why are they asking the question? You're going to get the answer wrong. So, all right, we've got a bit of a poll there, Guy.
Alrighty, and the poll is, which is the fastest, most scalable database? And it's a multiple choice question.
So let's see what people think about.
And for those that can't see it.
A lot of people like SQL Server. That must be pretty fast and scalable, I reckon.
Okay.
A lot of people deploy that.
There's a pretty clear winner though, isn't there? As we get multiple clicks.
Oracle's pretty fast. I've seen Oracle clusters in my time. That must be pretty fast.
People's first pick was Aurora because it roared out to something like 70–80%.
I don't think they can see the answers yet, mate. So
okay. We've got Oracle, Redis, Microsoft SQL Server,
Dynamo. Not everyone's voted, but the number of votes isn't going up enough. So just let's end that and show them the answers, what people have said.
Let's show them. We'll show you.
Okay, so a lot of people said Aurora because they listened to my slides 5 times faster. Has to be pretty good, doesn't it? MySQL, yeah, it's down the bottom. Postgres, DynamoDB. Okay, so again, this is just my opinion, but things like Redis that I haven't spoken about yet, I'd put that near to the top. then I'd put DynamoDB, but we're going to go over that later tonight as well. And then I maybe put Aurora third, and then a whole bunch of other things. I'd put them the same: Oracle, SQL Server, Postgres, and MySQL. I just put them sort of a nice fourth, equal fourth or something. But we'll go over some of those more challenging ones in a tick. Let me see. I'm just going to have a quick look at the questions because we're about to move on to a slightly different topic. By tuning, do you mean query tuning? Lucas, they do a lot of default tuning and based on the size of the instance you have. So if you have a 2 gig of RAM instance, they make sure they do some basic tuning to make sure a certain amount of that's used for indexes and a certain amount of that's used for database queries. And obviously, if there's some specific application stuff, that's where it's left up to you. You can do some work on the tuning as well. But for example, if you then scale that instance to 8 gigs of RAM, AWS will put some sensible defaults in for what a MySQL database is, if that's what you're running, will need on 8 gigs of RAM. So, so there's a lot of sensible defaults and sensible tunings you'll get out of the box. So you get probably 9 out of 10, 90% of the tuning that you need straight out of the box from them. They do a very good job. And then there'll just be the last bit of tuning that you need to tidy up. Does AWS have access to the data then, as they have admin rights? You can still deploy it on encrypted volumes, so the data is encrypted at rest. Yes, they'll have admin access to the machine. They'll have access to the data. That's right. So that might be a issue for some people, not others. Is there a limit on the size of the database supported by RDS? Yes. So the different engines all have different limits. So all these 6 all have different limits, and I don't know them all off the top of my head. Microsoft SQL Server used to be 300 gig, which is some instances small. I think it's something like 10 gigs and 30 databases, something like that, 10 gigs of database and 30 databases. But the different ones have got different limits. My guess is Aurora's got the biggest limits because they've sort of built it cloud ready. So there's another good reason to start with something like Aurora if you think you're going to get really big databases. Does RDS support multi-tenant instances? I highly doubt it. I'm not quite sure. I know what multi-tenant means, but I'm not quite sure about what your question is. You can stick more than one database on an RDS instance. So, so if you're a corporate, you might start up your RDS Oracle instance and stick half a dozen databases from different applications, if that's what you're calling multi-tenant. But if it's cross accounts, like a different AWS account, I highly doubt they're going to let you access that sort of thing. So, do they help you with, are you able to, I'm not sure what the first question is, so I'm just ignoring that one for the sec. Are you able to perform table or object level recovery, or do you have to recover the entire database? I'm not sure on that answer. They've got a lot of automated recoveries through the web UI and through programmatically, but it's usually point in time, so it's the whole database, I think. But I'll admit I'm not sure on the answer completely. So we're going to talk about, that's all the questions I've got. So I'm going to go back to the slides. Database scalability. So the first thing people see is that you have the RDS instances, and they're just based on EC2 instance sizes. And so obviously vertical scaling we already talked about last week. So you can start off with a small instance and go to a medium or large instance, and that gives you more performance, more CPUs, more RAM, more performance. You can scale some of those types horizontally with read replicas. You can use a faster technology like Aurora versus MySQL. You can do traditional performance tuning with better indexes on your tables and doing some better caching. But eventually you get to a limit. So you might have scaled up to a large or extra large instance, and you might have 5 read replicas, and eventually you can come to limits of what's reasonable, and what do you do after that? So databases don't scale horizontally as easy as web, PHP, and Java applications. That's just example technologies. But because they scale almost perfectly horizontally, and a database doesn't, because it's usually the reads that are scaling out, not the writes, and it all depends on your application. So what happens when we run out of scalability? So my first suggestion is at least start with Aurora. So that tends to be the most scalable SQL at AWS, because remember I said it was built from the ground up for cloud. So that will be doing a much better job. They now have a thing called AWS Aurora Serverless, which it still has servers. I don't know why they call it serverless. And it's basically an auto-scaling Aurora. So if you stop doing queries on it, it reduces down to 0 and you don't have to pay. And if you start doing more and more and more queries on it, it just scales up automatically, and they just charge you for how much queries and how much you're using it. So so that's a reasonable answer for scalability. So when it comes to scalability, think about sometimes you only need a low scale database, or the scalability is really known. You've got a set of users that do a set of queries, and it's really knowable. So therefore, there's a limit to how much scalability you need sometimes. Sometimes it's high scale, and you know sort of reasonable bounds of what it's going to do, and you get to 2 or 3 read replicas and you've got enough scalability. Or you go to what I call cloud scale, where you might have huge spikes in traffic. Someone might be doing a TV commercial, or someone might do a Facebook post, and then you expect all this big spike in traffic to come through. Or you might have a web shop and you do a sale, and then your database goes nuts for 24 hours. So so there's some things that you might need to really be able to scale up. And you need to match to appropriate technology. So a lot of questions in exams is about matching the technology. A lot of answers is just tick, if you don't know anything, just tick Aurora, and you've got better than 50% chance to get it right anyway. But a lot of this course is learning about the different technologies and then matching the right ones. So database scalability reached, what's now? So like I said, the read replicas only do so much, and they don't even help you write a lot. And so what do you do after there? So I talked, one idea is to simplify the application sometimes. Sometimes you can just make things simpler, less load on the database. But here's a cloud scale example. Say you've got a mobile game and 1 million users out there, and they need to access their account. Traditionally, so that would send a normal SQL database nuts. 1 million people trying to log in and access their accounts, and you may have trouble scaling to that. So traditionally, you'd write some extra code to try to cache it, to try to like tweak around the SQL problem. Or alternatively, you start with a better environment and a better solution built for cloud scale. So instead of having this problem to start with, if you'd thought ahead and started with a database that's going to match your cloud scale better off, you would have been in a better case to start with. So we're going to have a chat about sort of cloud scale now and a different technology. So SQL is what most people have seen for databases, and less people have heard of this thing called NoSQL. So SQL, this is just an example of the 2 different things. So this is SQL that you would know and love. So you've got rows and columns. Schemas are largely fixed. So adding columns and tables is a sort of slow thing to do, and it brings the database down usually. You use SQL to query it. And scalability, the main way you scale an SQL application is vertically. So I talked about read replicas, which is horizontal, but mostly it's about how big your instance can be. And this is what a SQL database looks like. You know, rows and columns. That's looks like a spreadsheet. And NoSQL looks very different. So it's key value pairs. The schemas are usually dynamic. They're usually thinking about things as documents rather than rows and columns. And they're built to be horizontally scalable. So now if you've got a database that's built to be horizontally scalable, and it's okay with 10 nodes, 20 nodes, 100 nodes, scalability or more, then obviously your database is going to go a lot faster. Yeah, so it's scalable for reads and writes, Anchor is asking. So yes, so these are built straight up, scalable, completely. So at AWS, what does NoSQL look like? Well, one example is DynamoDB, and it has tables full of documents. And in the labs this week, there's a good lab on DynamoDB, and I'm also going to do a demo on it as well. And then there's in-memory databases, and at AWS they call them Elasticache. So there's Elasticache for Redis and Elasticache for Memcached. And if these are in-memory databases, imagine how much quicker these are. So these are very fast. So super fast access, mostly as a cache for applications. They're very commonly used for web session storage. So if you've got a really big, say, e-commerce website, and lots of people have got a shopping cart, that's what a web session is, a shopping cart. And instead of storing those in a database that uses SQL, that has a write hit and read replica problems, why don't we just put those shopping carts in an in-memory database that's very scalable and keep that away from the main database? So that's one sort of tweak that's really quite easy to do on some applications and has a big performance impact. And again, Redis and Memcached, you can do them yourself. They're open source technologies, but again, it's the same argument, do it yourself versus Amazon managed. So a quick little tutorial on DynamoDB. So this is AWS's key value store. AWS has engineered this for throughput and resilience. So they're saying most changes to the database take less than 10 milliseconds, and it's synchronized over multiple AZs for availability. And you pay for the throughput that you use. So you pay for, it's very similar to paying for IOPS. But instead of paying for IOPS, you're paying for, they call it two different things, write capacity units and read capacity units. So roughly, just in rough terms, without getting into too many details, you pay for how many queries you're going to write a second, and you pay for how many queries you want to read a second, roughly. So you pay for the storage as well, but you pay for how many queries you want to do as well. And then Amazon works out how many nodes it's going to be on to achieve how many reads and writes per second that you're paying for. And they scale it, and they do all the horizontal scaling and managing of the database and the memory and everything. You just use it. You're just a consumer of that performance. So we're going to do a bit of a demo of DynamoDB to give you a bit of an idea what it is. But again, there's a lab on this. So I'm going to skip over the bits that the lab's sort of heavy on and do a bit more demo of the technology itself. So this is my DynamoDB. If you just notice, I've done it in North Virginia in a minute. And the table's called Game 1. I don't know. This is a game that I've made, a mobile game. And I can have a look at the items. So this is just a web interface for the moment. And we've got one, what DynamoDB calls a document. So gamer ID 1, that's me. And I got a miserable score of 12. I haven't been practicing enough, obviously. Let me just get up my terminal. And I'll just show you a few little programming things. You can program against DynamoDB in lots of different programming languages, and I'm just using command line for the moment. You can do things like AWS describe table. So this is just describe table game 1. So you're just asking Amazon, what do you know about this game 1 table? It's active. Its main key is gamer ID. It's a string. And I've provisioned it for 1 read and write capacity units just because it's cheap. So that costs, so this, to keep this database running, costs about 50 cents a month with one read capacity and one write capacity in it. So it can be fairly cost effective as well. Even if you scale it up to say 10 read and writes records a second, which can be a reasonable amount for some applications, it's only about $2 a month or something. So, you know, it's not ridiculously expensive. I'm going to run a scan table. So that's just showing me what's in this game one database with no query. It just says, so this is the document. So this is it's come back as a JSON document. And you can just see the record in there in JSON format. I'm going to put a record in. So I'll just show you what that looks like. So I'm going to upload a record for Peter. He scores 5. And look at this. He's got a bonus score of 2. And we're going to ask it to tell me about the consumed capacities. What of those CUs have been used for these queries. So I put up that record into table game one, and it said I used a 1.0 capacity units because I wrote 1 record per second. It was 1 record. And so I used my 1 CU. That just gives you an idea. So you can do more advanced queries, and it might tell you use 3 CUs or 5 CUs to do the 1 query. Now, if I do a scan, you can see both my original score and Peter's score. One thing you'll notice, if I come back over the web console, it's added this column for bonus. And I didn't have a bonus record. We didn't go and change the schema. We didn't do alter table, SQL alter table, add column, which usually freezes the table in most SQL servers. So it did that live. So that's a good advantage of NoSQL type solutions, is they're schemaless and it's live. I think that's all I wanted to show. I've got to put 2. I've got this query. Let's have a look at the query.
Are you going to play a game?
No.
Can I please play the game?
There's no game against it.
Ah.
That was just me faking that I haven't had much practice. So I'm going to run this command here in the middle, and it sends a query, and I've put the query in this JSON file. So here's the query. Go in and show me gamer.id of string 1, which, if you remember, is me. So it's a little bit like SQL. Select where name equals, where gamer ID equals 1. Select star where gamer ID equals 1, and it comes back with my record. So it's fairly simple, but what I wanted you to see is how I added the column live, and so that the schema can change quite quickly. Okay, I'll get back to the slides. Okay. And there's the commands in the slides, so you can check them out tomorrow. DynamoDB general features. This is some of the data types they have. It's schemaless that I talked about. You can add and remove attributes at any time. So a document, every time you add a document, it can have different, what we would think of as columns. And they can all be different as you go. And you can do things like triggers, you can have atomic operations, and you can do digital signatures and so forth. But one of the things people use triggers for, it can work with Lambda, which we don't cover at the moment. But basically, you can fire a HTTP event that goes and hits Lambda, that goes and does further processing. So maybe every time you add a record to DynamoDB, you want to go and create some more documents or process that further. So you can scale it out like that, scale out your application. So what's different? So indexes are very simple. There must be a number, a string, or a binary, and you can't have very complex keys. You can have 2-part keys, and you can have some global shared indexes. So there's some ways of getting some more keys into it. There's no built-in referential integrity, which is very different to an SQL server. So there's some differences, but it's built from the ground up to be fast and a consistent known performance level. And that's how you pay for it. So it's a completely different animal. So you might not want to write an accounting system on this. Okay, so why would you use NoSQL? So scaling is only part of the answer. So it's built to be fast. It's built for your database to match your code, especially in object-oriented environments, development environments. So your code models the business, and then as the code and the business changes, the database changes and keeps pace with the code without any underlying changes to the database. Often people make a lot of SQL modeling of the code, and it sort of gets very stuck in its ways because you've got tables and indexes and keys between tables. But NoSQL tries to do away with that. It's got the dynamic data structure, which we just talk about. It's collections and documents based. The code creates a database as it goes, and it's document database versus records. I don't know if anyone's been around since the 90s like me, but I used to do Lotus Notes Domino pretty much purely in the 90s, and it's a NoSQL database. So I've had a long experience in NoSQL and love it. So what's wrong? Why would you use NoSQL? So we've talked about performance and the code matching better from the business, and it's in its name, structured. So when you go and make an SQL database, like I said, it tends to be rigid and structured and ordered, and you make a choice at the start, and then when that's wrong, it's sometimes difficult to undo, and it's expensive to make changes to it. Variants generally require schema changes. So if you've got slightly different products, and then people start making workarounds in SQL databases, but when you've got NoSQL, it's built for that sort of thing, to have variants. As business changes requirements, SQL tables feel more rigid and restrictive. Oh, it's got a typo. Right. And SQL is, for example, very good at accounting. So because accounting really never changes, because it's got laws around what accounting is. But when you go to say something like social media engagement, you need a bit more flexibility, and it's fluid, and the environment's changing a bit more. So maybe NoSQL will favor that more because of the fluidity. So where might you use NoSQL? So you can't, if you've already got an application built in Oracle, you can't just go to the company and say NoSQL is better because it's faster and it's got reliable performance, but it's already built. So when are we going to recommend NoSQL? For startups, new applications, you might consider it for new applications, short-lived applications and business cases. High scale requirements where data doesn't need to be compared to each other. So SQL servers shine when you want to aggregate data, sum it and graph it and that sort of thing. They sort of shine at that sort of environment. So like accounting applications, you want to aggregate and sum, and you want to know the profit, which is addition of a whole bunch of rows. So that sort of thing you want an SQL database for. If you're looking for something that's agile, rapid, flexible, iterative, evolving, so you want to match the tech to ideas, people in the business, that's where NoSQL really shines. I think the biggest failure of IT is in matching requirements. So IT tends to go out and ask you ahead of time what you want, and then they're going to make a rigid program and a rigid database structure, and they give it to the business, and the business goes, well, that's not what we really asked for. We want these changes. And then that's when the trouble starts. So the idea of NoSQL is to be agile and rapid and flexible, and start small and grow fast. So how are we going for time? Pretty good. So I'm going to do some more questions now. Let me have a look at some questions.
And in the meantime, Scott, we can talk about the age contest that your Lotus or Domino Lotus was.
Oh, right. Yeah.
We got some people that were on the what was it, C64
Yeah, I'm a C64 man. VIC-20, that's where I started.
CP/M with Stuart, and I think Stuart's the chip leader in terms of going back.
Okay. Can you switch from Aurora serverless to Aurora when you grow to a consistently large size? You definitely can. Most of all the databases support doing a snapshot to Amazon S3, and then you can use the Amazon snapshot from S3 to recreate an Aurora server, and then you can take an Aurora server between serverless and back and forwards using the Amazon S3 snapshot. So yes, you can move around a little bit. How do we balance good security and performance on the database side? Data encrypted will be stored in security, but retrieval will be slow. I don't think that it makes a lot of performance difference these days, having things encrypted. All the modern Intel CPUs have got encryption hardware built into them, and they're so fast at it that usually, 1 or 2% of the CPU can outpace reading and writing from the disk in encrypted format. So I don't think there's really much performance considerations these days on encrypting data. I don't think it really makes any difference. So that's my answer to that. So you should be using encryption more often than not is the answer. What other languages can you use to interact with DynamoDB? I don't know the answer to all those, but I'm sure Amazon's got lots of different options, and I'm sure all the common ones are fairly well supported. So I don't know the answer to that one. How come the bonus columns didn't come back in the query? Yeah, I reckon they did. Let me have a look at that. Where's the terminal? Let's just do that scan. Where was that scan? And Peter, yep, bonus. Look at that. Came back in the scan. So because I asked to scan with no queries, it just brings up every document back in its completion. So it did come back. What do you pay for when you query DynamoDB and get a single record? Okay, that's a little bit complex, Randall. You pay for how much data that AWS had to process. So if you do a scan like this with no query and it goes across the whole database, they sort of count the whole database against your query. You can do reads either that are reliable or reads that aren't reliable, and they cost half as much. And each read is considered 4K. So it's per 4K read. So it's a little bit complex in it, and the writes are considered 1K. So the main way you work out your what things are taking, let me just do this. Oops, it's caps, that shouldn't. Let me have a look at this history file. And on the end here, table name, oh no, it mustn't be in those, must be in this put, resume capacity. So if I do this scan command now, and then put at the end of it, return the capacity, this is the way most developers learn about how the capacity units get used. So that one read, because I did it in the least restrictive method, and it's returned, I don't know, a lot less than 1K of data, they sort of use half a read capacity unit somehow. So I haven't returned much and the count as half. So that sounds fair to me. But that's the way you can really learn about how much your reads and writes are going to use. But roughly think about it as how many documents you're turning. One capacity unit is reading one document per second. That's one capacity unit roughly. What do you use to recommend for porting existing databases? Oh, top of the class, Payel. That's my next slide. So I'll get to that in a tick. Can you name examples where one may fall into trouble using NoSQL databases? Yeah. So when data looks very consistent, it's not going to change over time. Your columns are going to be the same. You don't want massive scalability. It's a very known domain or known business problem, then I wouldn't use NoSQL. Like I keep saying accounting, but all right, it's boring, and it doesn't change. Accounting's fairly well known. Like, they don't invent new versions of accounting all the time. So I'd be using SQL Server, that type of thing. But if you're building a web app, a mobile game, that sort of thing, and you want about add new features to the game, and you want high capacity, and you want cloud scale, and you might have 1 million game users on your iPhone game, that's when you use NoSQL. So you sort of got to match the right cases. Can you give examples what you mean by matched requirements? So, clients throw requirements at you, and like I try to give you some ideas in the slides. Maybe that question came in before I brought up that slide, but so this is where you'd use NoSQL. Startups, new applications, short-lived, agile businesses. Could this be used as a DB development tool to see where the requirements trend to? Well, I don't completely understand that question. How about data security and auditing on NoSQL? So you can turn on a whole bunch of CloudWatch stuff for your DynamoDB. You can put triggers in it across to, you can put triggers in to go and record things in CloudWatch. So you can do a lot of stuff like that for your own auditing. Can we use MongoDB? I don't think so, but you can roll your own on an EC2 instance. Either database level, I'm just reading this database level question, database encryption or disk encryption. Either way, the CPUs are so fast at encryption these days, modern CPUs, it's just really hard to tell the difference when the database is encrypted and not encrypted. It's not really a bottleneck anymore. So I wouldn't really use performance as a reason to encrypt or not encrypt a database. It's pretty smart to have them encrypted, obviously. If you have a large database on RDS, say DynamoDB or SQL, any performance impact as you're doing a backup? Right, so this is another thing RDS, Amazon, AWS, I mean, manages for you in RDS is all the backups and the snapshots. You give them a maintenance period where you want things to occur, and you usually use that for things like you want to resize the instance, you want to make it bigger overnight, and you give it a window because the database has to go down for that. But a lot of the backups and so forth, remember when we took EBS snapshots, they don't interrupt the database. It's the same thing with RDS. They do it in such a way, off a backup or off a replica or something to make it so that it just stays live. And as far as I know, there's no performance impact, at least on things like Aurora. So, but obviously, if you're using something like SQL Server and backups and snapshots in its environment may cause a slowdown, and that's what you're going to get. But I'm sure they built Aurora, so your snapshots and so forth don't give you any performance headaches. Randall asks, is simple DB still a thing? I'm not quite sure what simple DB is. It sounds like a NoSQL in-memory database, and obviously you can run that on your EC2 instance if AWS doesn't support it directly. So I'm hoping everyone thinks NoSQL is pretty cool. I've got a couple of slides left. I think we'll just, I've got 2 slides left, just extension slides. So, this is just me talking about Domino, this one. So NoSQL historically, so IBM Lotus Notes was probably the best known NoSQL database for a long time. It was really big with corporates in the 90s. And they did a great job of matching GUI features and fields to database fields. So again, it used this idea of a dynamic structured database, and it was very people and business focused. And it used the concept of a business document being routed between staff. And there's a Wikipedia entry for it. And they noticed it was a distributed document-oriented NoSQL database. And it actually lost out to Microsoft Outlook and so forth, because Domino attempted to do email, and it was pretty rubbish at email. So it lost the email battle, and then it lost They're more business-focused database app development environment as well, which is a bit sad. If they never did email, I'd still be doing Lotus Notes Domino today, I reckon. And someone asked about how you get your database into AWS, which was a great question. And there's a thing called a DMS. I'm sure it's going to be a 3-letter acronym, everything at AWS is. And there's a link to have a look at it yourself. And you can use this to migrate an offsite database into AWS. And you can use it. You can do it between the same DB vendor. Say you're going from Oracle to Oracle, or you can use it from between different DB vendors. So you might want to go between Oracle and MySQL, or Aurora, obviously, or you might, if you're trying to get things into Aurora, you might have an existing database, and it's $3 per terabyte. That's what they quote to move data into AWS over DMS. So if you click on this link, they've got a 2-minute YouTube video about how it works, and it's pretty cool. And I've got an idea that if you're going into one of Amazon's databases like Aurora, DynamoDB, or a couple of those other Amazon ones, that the DMS tool is completely free. All right, Randall had a look up. SimpleDB's gone, and DynamoDB's in. So yeah, DMS is actually a reasonably common question in the exams as well, how to get the database in. So that's the end of my slides, and I think that's the end of the questions there, Guy.
Beauty, yes. We'll end it about there, I reckon. Lachlan's saying he wished he knew about DMS before bash scripting importing 300 tables into RDS.
Yeah.
Sorry, couldn't help you, Lachlan. Okay, so that's week 3 done, which is really exciting. Thank you very much, Scott.
Quiz questions opening up sometime as well.
Yep, really shortly. Next week we'll be talking about security and how to prep for the AWS exam, and we'll also talk a little bit about the short course exam for this short course. So we'll give you an opportunity to go through a bunch of questions and earn yourself a course certificate, and Scott will give you the inside running on the big one. Yep. So that's very exciting. Thank you, Barry, and thanks for Jason. I know Jason's gone off to bed already, but yeah, thanks for everyone else around for their questions, and we'll catch you next week. Have a good week, Scott. Thanks very much for your time.
Thank you.
No, I'll let you end the meeting.
End the meeting. Yep, great.